All right, Algebra 2, we're back. We're going to do a couple of examples of putting data to a curve, particularly polynomial. I did a third order curve on here as well, just so you can kind of see what's going on here. So the first example, we're selling widgets, and we're going to talk about sales in millions, because we're major players, as a function of dollars spent in ads. Okay, so you're basically the marketing guy, and you're tasked with figuring out what's the best way to make use of your ad dollars, and we're kind of see if we can put some data to a curve here. So we found that after, actually this would be millions of dollars, right? So millions. We're spending millions of dollars, or selling millions of things. That's how it goes. Okay, so it says that after $1 million in advertisement, nobody cared. You didn't sell anything. You sold 0 million widgets. Okay. After $2 million in advertising, you sold 1 million units. And don't think that just because we're not selling as many units, we're spending dollars in advertising. We could be making more than $1 per unit, so that might be okay. So after $4 million in advertising, you sell 2 million units. And after $6 million in advertising, you sell 2.5 million units. Okay, so we have 4 data points here. So we could do as high as a third order polynomial, right? So this would be a constant, this would be a linear, this would be a quadratic, and then this would be a third order, a cubic polynomial. And let's go ahead and do that. So what we're going to do, we're going to choose the function we're going to use. It's going to be f of x, and we're going to do a third order. So it's going to be a x to the third plus b x squared plus c x plus d. And the idea is to figure out what this a, b, c, and d value, what those a, b, c, and d values are. So we have inputs and outputs here. So we're going to have 4 equations and 4 unknowns, and we're going to plug that into the matrix when we're done here. So we're going to replace all of for this first equation, we're going to replace all our x's with a 1, and our f of x is going to be replaced with a 0. So we get 0 resulted from $1 million in advertising. So it's going to be x to the third. 1 to the third is 1. So it'll be 1a plus 1 squared is 1. So it'll be 1 times b plus c times 1, or 1 times c, plus, and then the d just comes down. It's just 1d. Okay. Our next group here, we've got spent $2 million in advertising and sold 1 million units. So 1 was the result of, okay, now every x we're going to replace with a 2 for this new equation. So 2 to the third is 8. So we've got 8a plus, and then 2 squared is 4. So we get 4b plus, and then we have replacing this x with a 2, so we get 2c. And then plus just a d by itself. That's 1d. Okay. Next result, we spent $4 million in advertising and sold 2 million units. So 2 million units was the result of, okay, so we're going to go through here with 4s now. 4 to the third happens to be 64. So it'd be 64 times a. So 64a plus, and then 4 squared is 16. So it's going to be 16b. And then c times 4, c4, 4 c's. And then, of course, plus 1d. Now, finally, we spent $6 million and sold 2.5 million units. That was the result of, okay, so every time we see an x, we're going to replace it with a 6. 6 to the third is 216. So it'll be 216 times a. Plus 6 squared is 36, so it'll be 36b. Plus c times 6, or 6c, plus 1d. Okay, so we're done with kind of the messy part here. Now we're going to punch each of these coefficients into our matrix editor. We're going to punch in 1, 1, 1, 1 for our first row, then 8, 4, 2, 1 for our second row, 64, 16, 4, and 1 for our third row, and 216, 36, 6, and 1 for our fourth row. And then the column on the right, you'll just punch in 0, 1, 2, and 2.5. And I'm actually not going to punch that in. I did it ahead of time. And it tells you that A, we'll put it over here, A equals, it said 0.021. Tells you that B ends up equaling negative 0.313. C ends up being 1.792. And D ends up being negative 1.5. So the equation would be 0.021 x to the third minus 0.313 x squared plus 1.792 x minus 1.5. So it's going to be, actually, right, f of x equals 0.021 x to the third minus 0.313 x squared plus 1.792 x minus 1.5. Okay, now it asks, okay, what would this projected sales be from if we spent $10 million in advertising? So we're just going to figure out what happens when we plug 10 in for x, right? So it's going to be 0.021 times 10 to the third is 1,000 minus 0.313 times, well, 10 squared is 100 plus 1.792 times 10 minus 1.5. All right, let's see if we can simplify this, right? Times 10, so it'd be 21 minus, let's see, 0.313 times 100 would be 31.3 plus 1.792 times 10 would be 17.92 minus just 1.5. Okay, so it's going to be, well, I don't have a calculator with me, but if we just added 21 plus 31.3, or minus 31.3 plus 17.92 minus 1.5, that's going to give us how many units in millions we're going to sell as a result of $10 million in advertising. Okay, let me just erase this and we'll do the second one here. How much time do we have? Oh, we're good. Okay, so we're going to toss a rock off of a tower. Of course, being very careful to mind our safety. And we're going to use a position tracker to tell us the rock's position after certain periods of time. Okay, so the rock, we're going to talk about position as a function of time. And we'll say in seconds. So it's going to be meters as a function of time in seconds. Okay, so we took some readings. After 0 seconds, so right at the start, the rock was 30 meters above ground. So we must have been starting, our initial condition was 30, so we must have been standing on a 30-meter platform or something. Interesting enough, after 1 second, the position of the rock was 30 meters above the ground as well. Now, you might be tempted to think, well, the rock just didn't move. We were holding it for that amount of time. That could be the case, or we could have chucked it upwards, and maybe it arced and came back down, and 1 second later it came back to where it started. Now it's going to keep falling further and further, which is probably a more likely scenario. But let's see what happens here. It's after 2 seconds, the height of the rock is 20 meters. And after 2.5 seconds, the height of the rock is 11.25 meters. Okay. I am going to, since this is basically a quadratic system, and I know that gravity has a quadratic effect on a rock, I'm actually just going to choose these first three data points and do, instead of doing a cubic function, I'm going to do a quadratic function. So here's going to be our basis. It's going to be f of x equals ax squared plus bx plus c. Now I could do ax to the third plus bx squared plus cx plus d. I have a suspicion it's going to be redundant because if we give 4 data points and it turns out to be quadratic, I think a quadratic function is going to give us an accurate enough representation of what's going on here. So let's just do that. So now we just start plugging in points. We'll use these first 3 here. So the input is 0, the output is 30. So 30 was the result of, okay, so x squared, 0 squared, be 0, a, plus b times 0, plus 0, b, plus c. And then 30 was also the result of, well, 1 squared is 1, so it'd be 1a plus b times 1, or 1b, plus c. And 20 was the result of 2 seconds of input. So 2 squared is 4, so it'd be 4a plus 2 times b plus c. These are all 1s in front of here. All right, so let's punch these into our matrix here. We get, we're going to punch 0, 0, 1 into the first row, then 1, 1, 1 into the second row, then 4, 2, 1 into the third row. We're going to give it a result of 30, 30, and 20. And what's going to end up spitting out is -5. So it's going to tell us A equals -5, B equals +5, and C equals 30. So what that means is that f of x, which is going to describe this rock's position above ground as a function of time, is going to be -5x squared plus 5x plus 30. Okay, and it asks, what is the position of the rock after 3 seconds? So let's plug in a 3 here and see what happens. So we're getting -5 times 3 squared is 9, so times 9, plus 5 times 3 is 15. 5 times 3 plus 30. Okay, so -5 times 9 is going to be a -45 plus 15 plus 30. Well, -45 plus 15 is going to be -30 plus 30. That's going to equal 0. So actually after 3 seconds, that rock has hit the ground. Its height is 0, which is kind of fun. Actually, it's not fun at all. It's just hit the ground. What can I say? Now it's asking for the speed of the rock after 2 seconds. So if this is telling us the position of the rock, remember, change in position is speed. In order to find a function that describes change, we're going to have to take a derivative. So let's do that. You can either punch it into Wolfram, or if you've realized the power rule by now, that's fine too. But when you punch this into Wolfram, you're going to get the derivative of this function is going to be -10x plus 5. Okay, and now it's asking what's the speed of the rock after 2 seconds. This is going to tell the speed as a function of time. So it's going to be -10 times 2 plus 5. -10 times 2 is 20, or -20. -20 plus 5 equals -15. In other words, the rock's height is decreasing by 15 meters every second at that given point. Now it's decreasing, it's accelerating, but it's at that given point, it's moving 15 meters per second downward. Its position after 3 seconds is going to be 0. And we're done. Take care, guys.